national 55 national and international conferences and two IoT workshops with IIT Bombay. Also, I would like to seek permission with Professor Sangeetha to allow me to talk about the Scholars Collab for a couple of minutes.
Yes, sir.
Right. Thank you, ma'am. So, Scholars Collab is a platform where we are revolutionizing research by making it more collaborative, accessible, and rewarding. Our primary goal is to empower the researchers at all the stages. For faculties and experienced researchers, we are providing the enhanced mentorship opportunities, global recognition, work, networking, and collaboration, and monetization opportunities for research mentorship. For the students or early career researchers, we provide the dedicated mentorship by a pool of experts, also a verified high quality research code, and the support tools and centralized code and the centralized research code for the sharing platform. So whether you are just starting your journey or looking to expand your influence, we are here to make your research process not only more accessible but more awarding. I would like the I would like the Professor K. Sangeetha to take the charge of the insightful sharing.
Thank you, Lakshya, sir.
You're welcome, ma'am.
Good evening, everyone. I'm honored
Good
to
evening, ma'am.
good evening. Good evening to one and all joined the webinar. I'm honored to present a webinar on vehicular ad hoc networks challenges, the protocols that are used, and the IoT integration that is happening in the VANET through the Scholars Collab. I'm very much happy to share the session with them. I have been integrated with them for the past 1 month, and as soon as I joined over, they have given over the mentoring of the projects, various networking projects, and they have also given the opportunity to present my knowledge on the networking side also. Thank you very much, Abhishek sir, and also the team who are supporting over him in the Scholars Collab. And with all my insight on the networking and my special area MANET and my current area of network IoT and VANET, I'm happy to share a small knowledge about this area to the people present over in this session. Okay. So we can start over the session with a lighter sense of the small introduction about VANET. Hope my screen is visible to all
Yes,
of you.
yes, ma'am.
Okay. So today, car manufacturers are willing to increase the road safety by equipping and making them become computers on wheels, isn't it? So we are having more vehicles equipped with more sensors and computers and the GPS navigation systems supporting over with various interfaces and applications to support the communications effectively between the vehicles. Okay, so the vehicles now, most of us are traveling with sophisticated vehicles, and the vehicles are becoming our core part in the communication nowadays. So these vehicular communications are developing foremost in the European countries and also in Japan and China. We have a lot of various projects going on in the European countries, and basically all of them are developing from the wireless network only. So we have the basic VANET, that is vehicular ad hoc network, as we call it shortly. It is a form of network evolved from the MANET, mobile ad hoc network. And the MANET, we know that it is an infrastructureless network. ad hoc network, which is formed all of a sudden for a particular purpose. Okay, so I will just move on.
Ma'am, you are on mute.
Am I audible, sir?
Yes, ma'am. Yes, ma'am.
Okay. So we have the wired as well as the wireless network. Okay. The basic classification of the network. Wired in the sense we have the guided medium there, and in the wireless in the sense we have the radio frequencies communications happening over to enable the communication between the different devices. And in the wireless, we have the various classifications like infrastructure based and infrastructureless network. So, infrastructure in the sense we have the routers, inbuilt routers taking care of the communication between the wireless entities. For example, we have the Wi Fi network in which the communication is enabled. That is the best example for infrastructured wireless network. And infrastructure in the sense, we don't have any routers externally to support the communication. We just have the routers inbuilt in the specialized devices itself. For example, in the military area and all, we have the ad hoc networks formed over to have the communication between the different devices all of a sudden when we want the communication to enable, or in a disaster prone area where the communication have to happen over to for the disaster relief purpose. During the time and all, we can't go on and establish the network with the wires and with the routers and go on with the communication. So we will be having the specialized devices with the routers inbuilt in them, enabling the communication within the network. Okay, so that is an infrastructureless network. The best example is our ad hoc network. So like that, we have various kinds of infrastructureless network like your MANET, wireless sensor networks, where the sensors are there collecting over the various data and enabling the communication between the devices, and the sensors will be giving over the data to a particular sync node. Okay, it is a, processing manipulating area, and from the sync the data will be stored over and the communication will be happening and we will be making a decision. And similarly, we have one form of infrastructureless network. Here we have the VANET, where we have it is a form of network in which some roadside units are also there supporting the infrastructure as infrastructure, but highly they are infrastructureless only. They are highly dependent upon the wireless network only. And then we have the body area network, which is also developing now, based upon which the medical field is also evolving. So the main networks, the MANET and the VANET, from which our VANET has evolved, have the difference like this. So in the MANET, you have the devices, the mobile devices, the laptops, the PDAs, or the mobile phones communicating among themselves using specialized routing technology that they have, specialized management technology that they have within themselves without depending upon any infrastructure. Similarly, here also, these VANETs are also working and communicating among themselves based upon the different standard communication technologies like your LTE or DSR, DV, or your WAVE. I will tell you what are these network technologies. So, and they are also dependent upon some roadside units as infrastructures. So, truly, we can't say them as infrastructureless network. Okay, so like this, you have the classification of network and the overview of VANET. So the main uses of VANET are they are supporting the intelligent transportation systems. So, by the term intelligent transportation, we come to know about how the navigation can be done over, how intelligently the lane shifting can be done over, how transportation of goods can be done over, all these things can be taken over here. And similarly, we have the other uses as navigation and location based services, where based upon the location, the people are getting various supports. Suppose I want to know where the football match is going on in the city. Okay, so all the services can be got when I am on a travel, okay, in my car. So if these services are not available in our country, these services are available in European countries or some Japanese cities, okay, with the specialized vehicles. So, and also navigation system supporting where I can get over the coolest some drinks or other things. That notification about the restaurants, all those things can be got over when I am on a travel. And also the emergency services like which is the nearest hospital, or when I am traveling, when I am having my relatives in my in some of the ambulances, and from the ambulance to the doctor's vehicle. Okay, if the doctor is also on the move. Okay, so all this communications, emergency communication between the ambulance and the doctor, or between the uh, doctor's vehicle, okay, that can be enabled with this one. And also vehicle to vehicle, this is what I have been telling, vehicle to vehicle communication or vehicle to infrastructure communication. These are the two types of communications happening in our VANET. So that can be done over here. And entertainment, infotainment, this I have been telling you about, where is the current theater play going on in the city, and what kind of uh, games are going on in the current uh, nearby stadiums. All those informations can be got over through this vehicular ad hoc network. So these are some of the uses. And coming on to the technologies that are supporting the communication, these are the three important technologies supporting the communications. We know that in our Wi-Fi, wireless network, infrastructured network, IEEE 802.11 is having a great role, and we have various versions of IEEE 802.11. So similarly, here also we have a specialized IEEE 802.11p. Okay, so the supporting over the VANET with the specialized physical medium, and also the medium access control protocol. These are the two layers which have to be distinguished in all kinds of network, whether it is a Wi-Fi, or whether it is a MANET, or whether it is a Bluetooth network. Whatever network, this physical layer, and also the MAC layer plays a role. And other part of the application and network layer, the routing protocols also may vary, but there can be some compatibility between these networks. But there will be a major role played by this physical layer and medium access control layers. So they have been evolved based upon this IEEE 802.11 Wi-Fi network with the specialized standard 802.11p. And this is the specialized communication standard adopted for our Wi-Fi network, that is DSRC, that is dedicated short range communication, which allows the direct communication between the vehicles and the roadside units for supporting the intelligent transport system. And the next important communication standard is WAVE, the wireless access in vehicular environment. This is also an IEEE standard supporting the interfacing of all the various protocols, the supporting protocols of your Wi-Fi, various supporting wireless protocols with our vehicular network environment. So these three technologies can be used separately or combinedly in our VANET environment. So just we can see the characteristics of VANET environment and move on with how the VANET environment is designed, and then we can move on with the other things. So we have the characteristics as the first one is high mobility. The VANET, of course, we are having the MANET in which the devices are also moving, mobile, they are moving. But here it is a vehicle. The vehicle may be moving on with the 100 kilometer per second, 100 kilometer per hour, or like that. It may be moving on. So high mobility, vehicles move rapidly. So definitely there will be a dynamic network topological changes which we have to adapt, and there won't be a patent mobility. Okay, so here we can't predict the pattern of the mobility easily. The moment is they are restricted by the roads, how the roads are, and what are the traffic rules. If we are moving on in a hilly region, if we are moving on in highways, based upon that, the traffic pattern, the mobility pattern may vary. And we have vehicle to vehicle and vehicle to infrastructure communication. Some more communications are there, I will let you, some more links are there, I will let you know. These two are the vital communications for the data exchange, and they are basically infrastructure independent. As and when the infrastructure comes on the way, the roadside units, the infrastructure that is present here is the roadside units. As and when the infrastructures are coming on the way, they get over the support from the infrastructure. Other than that, they are truly infrastructure independent. And we need high computational power also, but there is no need of shortage of power here, as in the case of MANET, or as in the case of ad hoc network, or as in the case of Bluetooth network. There is no shortage of uh, power constraint, but here we need high computational power, because we are operating on modern vehicles where we have lot of powerful sensors and storage and processing capability. So lot of power consumption is that. So that one is also a characteristic and also a constraint also. And then we have time criticality. So many applications we need to deliver the data faster, then only the user will be satisfied with the applications and the communication. Otherwise, the data will be going obsolete, and there will not be any use of the lately delivered data. Okay, so we have to deliver the data on time. And because of high mobility, we have rapidly changing topology also. These are the main characteristics of VANET. Hope it is clear to all of you. And coming on to the architecture of VANET. So we have the roadside units. They are the infrastructures supporting the communication. They get over the data from the gateways from the internet using the GPS. They will be getting over the data, essential data that has to be delivered to the vehicles. Suppose they are in need of the entertainment related informations, or they are in need of emergency informations. All those informations will be stored over in the roadside units, or some traffic related informations, traffic diversion information have to be delivered. All those informations are given over via this roadside units to the vehicles that are traveling over. The vehicle to vehicle communication can be enabled, and vehicle to the roadside unit can also be enabled. And the roadside units can also have a inter related communication. Networking can also be enabled so that they can exchange whatever data that they are processing, they can exchange also. Okay, so this is generally the vehicular ad hoc network. So this is yet another picturization of the vehicular ad hoc network, and this is the roadside unit. And the base stations, the gateways supporting the communications, and you can have the pedestrian communication also, vehicle to pedestrian, the people who are using the mobile phones when they are on a walk. That person also can communicate with the vehicles. Okay, that pedestrian communication is also possible. And you can have also this uh, communication units within the vehicles, enabling the communication, vehicle to vehicle communication. So these are the main architectural components that are available, the roadside units and the displays that are present over for displaying the information, the sensors sensing over, the application units and the object units for getting over the data from the application units, onboard units. Okay, and the GPS system enabled, and also whatever sensor units front, back, and also within vehicles, that are the components present over in the VANET, enabling the communication with the roadside units to get over the essential data. So these are the units, application units supporting the applications run over in the car, and the onboard units processing the data, and the roadside units giving over the data to the application unit and the onboard unit within the car. So these are the different types of vehicular links that are present. That is vehicle to vehicle, one vehicle to another vehicle, and vehicle to infrastructure, that is the roadside unit or the gateways that are present, and vehicle to pedestrian communication. Any person who are on the walk also can communicate with the vehicle. So these are some kinds of other links and different names given over for the links that are present. So vehicle to vehicle communication, which enable the data exchange between the vehicles directly. What kind of data they may be exchanging? They may be exchanging what is the position, what is the speed they are in, and what way they are moving on, heading on. This will avoid the vehicles about collision, and if they are about to go for a lane change or they need some cooperative maneuvers, all those things can be supported when they are on the move, when they communicate with other vehicles. And when do they need this vehicle to infrastructure? The roadside units or any traffic infrastructure. Okay, so like the traffic lights, road signs, or the toll gates. Okay, so here they will be exchanging in the informations about the timing, the current messages, the road hazard warnings that I have been telling you, that something hazardous traffic have happened or accidents have happened. All those things can be informed to this vehicle so that they can take diversions, and the speed and the lane recommendations, all those things can be given over by the roadside units to the vehicles. And what kind of information that can be got to the vehicle from a network, from a gateway. Okay, so we can be getting over the information, backend servers information or the cloud systems informations, like your traffic information or over the air updates, the latest information. Suppose some cyclone is coming over, okay, or something hazardous has happened all of a sudden, that information can, radio informations can be broadcasted here. And some infotainment connectivity, isn't it, that I have been telling you, that any kind of information or can be given over from the cloud. And vehicle to pedestrian, when these two person, the person on the move on the roadside and the vehicle, they will be communicating, means they need some smartphones or wearables they are going on, and they want to inform the pedestrian about some possibility of conflicts or about the road blinds, or to the vehicle they want to inform. All those things can be given over between the vehicle and the pedestrian. And when the vehicle and the cloud will be communicating, means of course for storing over the large information that they have got, this vehicle has got, they will be storing over in the cloud, and from the cloud they will be getting over the analytic part of information, so that they can make decision based upon the analytic parts that is coming over from the cloud. Okay. And coming on to the vehicle to device, any other device apart from the vehicles, some other devices can also be contacted. Suppose it may be ambulance, or it may be any vehicle, or it may be any electronic application, like your mm, ECG machine, like that. All those things can be contacted. And vehicle to grid, this is the very developing area where we have the electric vehicles communicating with the power charging stations, and how the charging, discharging, and the balancing of energy is maintained over. All those things are taken care under this vehicle to grid communication. Like this, you have variety of vehicle to everything. This is V2X, vehicle to everything, link establishment types are present. So these are the variety of links present over in our VANET. And when we come on to the links, what are the nodes involved? When we go for V2V communication, we have the uh, onboard units communicating with each other, and the communication technology that is supported is, it may be IEEE 802.11p, or it may be car V2X technology, or the personal communication 5 technology, like that. These technologies can be supported, and the primary application is collision avoidance, platooning, like that. And here we have a lot of challenges: the network fragmentation and high mobility. The network may be splitted out, okay, and we may have to communicate with the vehicles effectively when they are moving with a great speed. And when we will have this V2I, during that time, these two units are communicating, that is onboard unit and the roadside unit are communicating using these technologies. And why they are communicating? For traffic management, for the internet access, all those things they are communicating. And the challenges faced over here are infrastructure deployment cost. So RSUs, we can't get the RSUs just like that. They are supporting the communication. So we have to have the infrastructure deployed. So it costs over. And then we have the vehicular to vehicle to network communication. During that time, the cloud is being communicated, cloud servers are being communicated. And of course, we will be using our LTEs or the 5G technologies, cellular network for the communication. And why we are going for that one? We go for mainly the infotainment, or how the movement of the vehicles is going on. For all those things, we are going for that. And definitely we will be facing network latency and coverage problem here. And when we go for the vehicle to pedestrian communication, these two units, pedestrian device and the pedestrian device, means their mobile device or the mobile uh, smart watches or whatever maybe that they are wearing, and the onboard unit are communicated. So how they are communicated? With these technologies, using Bluetooth or some 4G or 5G network, they will be communicating. And especially for the pedestrian safety or for the VRU protection. And definitely the power consumption is a key challenge here, and also the device penetration rate. How often this pedestrians are getting into the VANET network? So they are penetrating into network. So how often they penetrate? That is also a great challenge here. So like this, variety of links, what nodes, are involved and what technologies are involved, what are the applications for which the communication is happening. And now we also discuss about the road safety related applications, getting on into the variety of road safety related applications. So here there are various use cases related in the road safety. So the first one is the intersection collision warning. It is also a very important thing. So for example, I am communicating with another device means, so I am intervening with the communication that is happening in that vehicle. So how often I am communicating, with what mode I am communicating. So periodic message broadcasting, with the periodic message broadcasting, I will be communicating. So with that one, and what kind of frequency that is being used over. Of course, with the minimum frequency of 10 hertz itself, it can be satisfied. Of course, you will be having the latency here also. And other use cases related to the road safety or the lane change assistance. Okay, vehicle to the roadside unit, you will be having a lane change assistance. So here you will be having the cooperation awareness between the vehicles, and also overtaking vehicle warning, that can also be an important application. Here we will be broadcasting the information to the different nodes that are in the area. And head-on collision warning, of course, what are the collisions that have happened earlier on the road, on the way. Okay, that will be intimated to the vehicles before reaching that place. That one will be, so it will be of course a broadcast message with all happening in the 10 hertz, minimum 10 hertz frequency. And yeah, yes, someone has raised the hand, I think.
Oh, sorry, ma'am, by mistake. Sorry. You can continue.
Okay, okay. So, I have been telling about the road safety related applications. Here we are having the head-on collision warning related to the traffics that are happening ahead, intimating the vehicle priorly. And then we have the cooperative forward collision warning also, which happens between the vehicles. So here, vehicle associated with them will be transferring the unicast information, that is one-to-one communication will be happening between the vehicles. They will be discussing among themselves. And emergency vehicle warning, something have to be happened, emergency assistance. Suppose the driver needs an assistance, or some person within the vehicle needs an assistant, means that information have to be broadcasted so that the roadside units gives over to the emergency ambulances that are on the road and get over the support to this vehicle. So like that can also be happen. And then cooperative merging assistance. So here the awareness between the vehicles for again supporting the information via one-to-one node assistance. And then we have the collision risk warning also, between the periodic messages, between the periodic events that are happening over. Everything is happening with a latency of the delay of 100 millisecond, and also with the minimum transmission frequency of 10 hertz. So these are some road safety related applications that are happening in our VANET. So apart from this, now we are after getting over an insight about the VANET, the components, the vehicular links that are present, and what applications that are used over in the VANET. Now we are heading ahead with the security services that are provided in our VANET. So we know this VANET is supporting a very important information that is being transmitted between the vehicle to vehicle or the vehicle to the roadside unit. So how far they are secured? Okay, so that has to be a great challenge. So here the security challenges like availability of information. Okay, whether the information is available at the proper time. Okay, so that one has to be dealt over. And the confidentiality of the information, whether the information is secured. If I am transferring some information related to my uh, banking information, some banking information I am doing with my bank on the move means, so how far it is confidential. Okay, so I will maybe getting the support from the roadside unit, or I may be getting support from the cloud services during that time on the move, how far it is confidential, because there may be a lot of hackers on the network. So how far it is confidential, that is the one. Then authenticity, really I'm getting on into the service, so how I am being authenticated. If I am getting information about some information, if I am authenticated and I am able to access the information properly, and integrity of the information and non-repetition of the messages that are being transferred have to be verified. These are the important security services that should be available among the VANET. And of course, you can have the variety of attacks on the VANET. You can have the active attacks, you can have the passive attacks, or you can have the insider, outsider attacks. Insider attack, the person may be present over within the network and they may be giving over the information among the other devices. Outsider attack, the roadside unit may be a malicious one. It may have got some attacker and the roadside unit may behave maliciously. That one. And generally, malicious attacks and the rational attacks, the local attacks, the extended global attacks within the servers, cloud servers, all those things are possible in a variety of possible ways. So these are the different attacks that are present over. So we can see the attacks one by one. So what are the attacks on availability? So availability is how far the data is available to the user on the VANET. You can have various attacks from the users. For example, DOS attacks, denial of service. Just a minute. Yes, you can have the denial of service attack, or you can have the service jamming attack, or a malware, malicious software may be introduced into the application, VANET application, and your VANET application may be behaving maliciously. And broadcast tampering, this is the most prominent attack happening over in your VANET. That is, when we are broadcasting the information, of course, lot of things we have been broadcasting only. So here we can see the broadcast. Every messages are happening over mainly broadcast only. Very rarely we have the unicast communication happening over. So during that time, broadcast tampering is highly possible. And you can have the black hole attacks or the malicious gray hole attacks. And you can have some greedy behavior among the users, that is they will be sharing over the informations for additional charges that they are having. Okay, and spamming up of wrong messages. Okay, or more messages coming over, advertisements coming over, that is also possible. I am advertising about my company or some restaurant, often for the vehicles on the move, means it may be a disturbance to the vehicle. Okay, so the channel may be collapsed here. So like that you can have the attacks on the availability. So the information have to be available properly without denial, without jamming, without introducing malwares, without having broadcast tampering, without having all these attacks and spamming up of the information. So these are the attacks that should be avoided. So we should develop the security protocols in such a way that these are handled. And then we can have the attacks on confidentiality like eavesdropping, traffic analysis. When we are moving on with the lot of broadcasting of information, the traffic may be analyzed by the hackers and man in the middle. So some hacker may be in between the vehicles. Okay, they may be in the roadside unit and they may be attacking from the roadside unit and giving over wrong informations like that. And there are some attacks on the social media also like this. The confidentiality attacks also possible. Secrecy may be left over. And there are attacks on the authenticity also, verifying of the users properly, whether the user is a proper authenticated user to access the information. That one is also a great challenge here. So you have the Sybil attacks, you have the tunnelit attacks, the GPS spoofing attack, the GPS position may be compromised here in this GPS spoofing attacks, and node impersonation, because I may be acting, suppose in an emergency case, I may contact a ambulance using the roadside unit, but uh, the ambulance may be a impersonized hacker who may try to divert us. Okay, so the node impersonation is also possible, giving out wrong information because of hackers. And the free riding, the replay attack, again playing over the wrong information so that it becomes the actual information. And the replication of the certification key compromisations are also possible. And again, message tampering because of the compromise of authenticity is also possible. These are the different kinds of attacks under the authenticity. And again, coming on to the attacks on integrity, masquerading, hiding over the original identity, and giving over wrong information, and replay attacks, message tampering, and illusion. You give over a wrong idea that uh, the information is correct, that your information is correct. You make the user believe that you are giving over a correct information, like that a wrong illusion is given over to the vehicle that which is accessing the information. Like this, lot of attacks on the integrity is also possible. So we have to develop uh, the security protocols. These are the different variety of security protocols supported for the VANETs, cryptography based protocols, the trust based protocols, and the hybrid models. The combination of cryptography and the trust based protocols are also available. So these are the various attacks that we have been discussing over now, and where these attacks are possible. They are possible on these communication types, and how far the attacks are also having the risk factors, whether the risk factor is a major one or they have to be immediately dealt over critical one, or they have to be tolerated to some extent with the minority level. Okay, so like that the variety of attacks have been listed over, and which type of security service is compromised here. because of these attacks. That is also given over. You can explore them. So these are the security protocols that are supported under the VANET. All the security protocols are emerging based upon the VANET protocols and the wireless sensor protocol. A combination of them, they have been coming over. And some of the protocols, I will give you an overview. Just a minute. Yes. These are the protocols, and they are the security protocols. And this protocol, it is based upon cryptography, and the main security mechanism that is given over is the digital signature. Okay, so how the digital signature can be taken over here. Okay, so that is the security mechanism involved here. And what kind of security issues are addressed here because of this protocol means you have the authentication, data integrity, and also the non-repetition being addressed over here. And it is very good in the packet delivery ratio. And but here you have high overhead. And related to scalability, how many number of devices that can be supported over here? Okay, so that is a great question here. It cannot be addressed over under this protocol. And coming on to the next protocol, it is also a cryptography based protocol supported with the symmetric cryptography and authentication security services addressed over here. And here you can have a good scalability of the devices. You can support as many as devices within this protocol. And here everything is average. The packet delivery ratio is also average, and the scalability is also average, but the overhead is low. That you should consider. When the overhead is low, the network may be stable for longer period. Okay, so that can be considered here. And all this security services are addressed over. Many security services are addressed over here. So it can be considered as a good protocol related to cryptography. And you have this protocol, yes, Brave, related to cryptography, supported with the certificate mechanisms, addressing the authenticity and integrity. Here also, everything is good, but the scalability is average. Only medium number of nodes it can support, but the overhead is high. Like that, you have variety of protocols, security protocols evolving over here. Based upon the trust, also based upon the hybrid model, you have two more protocols supported with the digital signature and certification. And they are also good and average at the scalability. Scalability relates to how many number of nodes that are addressed over here, and overhead relates to how many number of packets, additional packets, control packets that are being transferred. And this is the packet delivery ratio, the throughput that we are getting over because of the routing protocol. And these are the VANET security challenges and related solutions that are being offered. That is the various security solutions for the network area, how for the network clustering have to be done over within the related vehicles. Okay, so for that, we have a limited coverage and fixed cloud servers, which can be offered with mobile brokers as service providers. Intermediate mobile agents or the brokers can be introduced over so that the network area challenges can be sorted out in the VANET. And we go for the Internet of Vehicle Communication. When we go for the VANET and the IoT integration, lot of security issues are coming over, which can be sorted out with all this wireless security protocols and authentication things. And when we go for the cloud or the edge applications. All these challenges can be sorted out with the blockchain mechanisms and the decentralizing the MEC. And we have the applying in-vehicle informations solution can be got over with this in-vehicle devices, integrating various in-vehicle devices. And that is a great challenge. And we can go for the supporting compatible manufacturing devices offered with various companies. And quality of service is also a great question. So for that, we have to go for offering time sensitive traffic information so that the messages are being delivered and there is less latency, and the delay is reduced, the jitter is reduced, like that. All those things can be taken over. So you have variety of security challenges for which the solutions are also offered over here. Some more security challenges and their solutions. For example, location sharing. When we are sharing over the location, you get over the challenges like whether it is a proper location, or whether we are having the privacy of our location information. Suppose I may be in a compromised area, okay, which it should not be revealing. I may be in a emergency meeting which I should not reveal, but because of I am in a VANET, that may be revealed to other some of the vehicles also. So how it can be avoided? That can be using some secure sharing mechanism, some trusted authority in neighboring vehicles. So we have to encourage the neighboring vehicles to be a trusted one by giving over credits to these vehicles for sharing over our information secretly. So like that, location sharing can be a great challenge which can be sorted out with all this one. And car accidents, for taking over the car accidents, we can have the challenge like high speed driving and the driver cannot stop the car physically, like that. Lot of challenges can be faced. So for that, we can go for integration of the IoT. The sensors have to be enabled properly, and we can go for the AI techniques to control the speed and the brake system automatically. So like this mechanism have to be inbuilt. And parking management, for parking management, we can go on with the smart parking system, which we are using with a lot of sensors inbuilt in our vehicles. And like this, we have a lot of security challenges, and which are given over with the various solutions under the various papers. Apart from the security challenges, which we have been discussing now, the security protocols, the attacks we have discussed now, and the security protocols that have been evolving, and what is the technologies that are used in them, and what for they are supporting. All those things we have discussed, and also the security challenges and the solutions we have discussed. Now we are getting over into the networking and the communication side challenges. So apart from the security challenges in the VANET, routing the information, when we are transferring the information from one vehicle to another vehicle, or the VANET to the roadside unit, or the VANET to the cloud unit, we can have the challenges faced over like this. So we may need a reliable and efficient data dissemination system. We may need a proper routing protocol, and the network congestion and high mobility have to be taken care. These are the challenges we are facing when we are routing the information. And quality of service is also a great thing. QoS provisioning, that is the throughput, the delay, all those component balancing have to be dealt over. So these are the different routing approaches that are happening over in our VANET. For example, you can have the unicast communication supported, one-to-one, vehicle-to-vehicle communication supported with all these routing protocols. evolved routing protocols in our VANET. You have the ad hoc routing protocol, that is ad hoc on-demand distance vector AODV here also supported in our VANET with a little evolution. And then you have the GPRS, the General Packet Radio Services for delivering the data, and you have the vehicle assisted data delivery, the VAD, and the DSR. These are the common protocols that are used in our wireless network also. They are evolved little bit in our VANET. And apart from that, you have this GSR, CAR. These are specialized protocol for our VANET. Position-based multi-hop broadcast protocols. These are specialized protocols. And then we have a broadcast mechanism also supported. The main thing happening in our VANET, that is, you have the communication given over to many vehicles that are on the move in the coverage area. So you will be broadcasting the information so that it reaches many vehicles, all the vehicles in the coverage area. And geocast is nothing but using the GPS, we are giving over the location based information. That is geocast. So distributed robust geocast protocol or the robust vehicular routing protocol. Robust in the sense it withstands the error, even it fails to some extent, it withstands the error and runs to almost delivering the data. So like this, you have three kinds of routing approaches: unicast, broadcast, and geocast. And we don't have the multicast and all given emphasized here. And related to the routing in VANET, it is supported in this way. And now, after seeing all the challenges, the introduction about the VANET, and after seeing all the challenges, security related challenges, routing related challenges, now we are getting on into the main concept of how the VANET and the IoT are integrated, and we are got over this IOV. Okay. So why we need this one? Internet of Things and the VANET. The main application of Internet of Things is we have the communication happening over in everything that is present in our network. For example, the smart home application or the smart irrigation system, which is supported. For example, I want to irrigate the agricultural field when the soil humidity is less. I want to irrigate the agricultural field. So for that, the humidity sensors are inbuilt in my field, and when the humidity level goes down, it will be sensing that one, and the actuators will be owning, and the irrigation will be happening when the humidity level is going below the threshold one. This is a smart irrigation system. Without my intervention, the motor will be running and the irrigation will be happening in my field. So that is a smart irrigation system. And similarly, we have a smart home system and a smart transportation system like that, involved in the with the help of lot of sensors, that we know it as Internet of Things. In everything we have the sensors, and with the integration of internet, all those things are working and supporting the human to have a sophisticated communication system. So that is Internet of Things. And we know what is a VANET. So vehicle to vehicle communication is happening. So when these two are integrated, we will be having a great Internet of Vehicles, which is evolving with a more smarter network on the move. So your network will be a smarter one on the move itself. That is IOV. So what are the sensors? So we know IoT is deployed with lot of sensors. So what are the sensors that are present over, and what are their primary functions? and what is their application in our VANET. Okay, so that one is listed over here. We can see an overview of this one. So when we have the camera deployed in our VANET, so the primary function is getting over the visualization. Okay, so that is the main primary one. And when we need this visualization for getting over the traffic sign recognition or the pedestrian or cyclist detection or the lane tracking or driver monitoring purpose, we may need this one, camera information. And when we need this LiDAR sensor, during that LiDAR sensor, we may need it for proper location support or for mainly detecting over the objects that are on the move. Okay, so for detecting over or for tracking over the objects, we may need the LiDAR sensors and radars. So especially for when we are going on with this blind spot monitoring or collision avoidance, during that time, we may need the radar. And when we go for the GPS system, especially for location awareness or for moving out of the navigation area, geofencing, or for other services, fleet tracking, whether the package is moving on in the vehicle properly or not. For that one and all, we can have the GPS system enabled. And then we can have the IMU units for measuring about the motion of the vehicles, how far the vehicle is accelerating and moving. Okay, all those movement of the vehicles can be got over, whether the vehicle is in a proper movement or in a deadly movement. All those things can be got over with this IMU sensors. And we can have this CAN bus sensors or the OBD sensors too for monitoring over the internal vehicles and the diagnosis. So CAN is the integration of the sensors, and you can have a distributor network among the sensors in your car. That is CAN. Okay, so with the integration of all the sensors, how the vehicle is internally behaving, whether the internal vehicle is properly working, whether the engine is properly working, whether the proper tire pressure is maintained or not, all those internal details about the vehicle can be got over. So predictive maintenance for purpose and usage based insurance. Okay, so before the vehicle tire uh, is depreciating, we have to change over. So all this one related to insurance and remote diagnostics, engine maintenance, all those things, we need the scan. And then we have this vehicle to everything modems, that is OBU units, onboard units, taking care of the hazard sharing and intersection collision avoidance and platooning. So these are the important applications of the various sensors that are inbuilt in our VANET. So this is how the IoT and the VANET are integrated, and we are having a great application in our VANET. So we are exploring how the VANET and the IoT cloud integration is happening. So we have a lot of intelligent applications predicting over the traffic, predictive maintenance of the vehicles, and autonomous driving. This and all the intelligent applications. And for supporting that one, you have all these sensor layers which are present in the physical layer, and you have the edge layers taking care of the real-time analytics and sensor fusion and local machine learning interfaces. All these things are happening over, and they are transferring the data to the cloud layers, and with the help of the cloud layers, all these intelligent applications are working over the processed information and giving over the right direction of information to the vehicles, command action to the vehicles, what information they have to properly process. All those things are given over, and based upon that, they will be making some decisions. Okay, so this is how the cloud integration is happening in the VANET and the IoT. And these are the applications of IoT integration, the traffic optimization and intelligent traffic. And you can have the connected and autonomous mobility applications, and the cooperative safety and emergency rescues, and environmental monitoring and urban sensing. Something hazardous is happening in the environment, all those things can be monitored. We can see them one by one. So traffic optimization and intelligent traffic. This is a very important application of VANET and IoT integration. So because of which smart traffic management data is transferred with the help of the sensors that we are using, the traffic cameras, inducive loops, roadside units are involved over, and with the help of the edge devices, we will be processing over the data, and the information will be stored over in the clouds. And finally, the information, the processed information will be given over to the system, and the system will be making over the information, traffic intelligent information, and making over proper decision with it. So this is how the IoT integration is done. And coming on to the connected and autonomous mobility management systems, there you have the autonomous mobility management connected vehicles with cooperative communications happening among them. So here you have the clustering of vehicles. Clustering of the vehicles means the nodes will be communicating among themselves using a cluster management system. So there will be a proper cooperation within them, and they will be sharing the information. So clustering of information is happening. And then you have cooperative safety and emergency rescues, where you have some hazardous things happening on the way, and the vehicles are being informed via the roadside units, because the cloud information, cloud data has given over the information to the roadside unit, and the roadside units are disseminating the information to the various vehicles that are on the move near them. Okay, so this is how they transfer. And the environment monitoring and urban sensing informations are also being transferred about how the weather is, how the air quality is. All those informations from the cloud are being transferred to the vehicles on the move using the roadside units. So like this, you have the various IoT integrations happening in the cloud-based, fog-based, that is fog-based in the edge nodes. It is being happen, intermediate nodes, and AI and machine learning driven integrations are also happening, and security and privacy solutions are being also given over with the help of the blockchain interventions. And these are some safety solutions given over for the VANET for the various hazardous things that are happening over in the VANET IoT things also. You have a lot of safety measures to be taken care when we go for the VANET and the IoT combination also. So these are the security challenges. Here also we face, similar to the VANET environment, here also we face all these kinds of attacks, and they have great impact, and the security protocols have to be developed for this one also, VANET and IoT also. And we have a lot of solutions for the VANET and the IoT environmental solutions are also for air quality monitoring, for the weather monitoring, and for the noise disseminations that are happening over when we are having proper schools nearby, means we have to go for this one also. And we can also have the energy related challenges when we go for the IoT and the VANET combination. So IoT, we have the sensors deployed based upon the battery. So VANET is one running on the energy, full energy, but the sensors are running on battery, so we have a greater challenge between integrating the sensors and the VANET. So you may face all these limitations of the energy related also. So you have a great challenge in trade-off happening over when the energy and the communication is also going on. And then you have the challenges related to the VANET here also. And there are some interoperability challenges that are happening over in the VANET and the IoT system also related to the heterogeneous communication standards, semantic incompatibility, application layer fragmentation, and cross-domain integrations. You have a lot of communication challenges. And related to the scalability, how many number of devices that can be supported here? You may get over network congestion if the devices are highly increasing, more devices are present, and it has to be if it is traffic congested area means more devices will be present and you will have the usage of the wireless link congested, and there may have a link instability also when we are moving, and we can have a edge overload also when we are having many devices. So, and multi-domain scalability, we are having the IoT, WAN, cloud, lot of multiple domains integrated together. So during that time, scalability is also a great issue. So like this, you have great challenges in integrating the VANET. So even though you have lot of applications, there are lot of challenges related to security, related to the environment, related to the energy, related to the scalability, related to the interoperability. All these things you have lot of challenges. So which have to be addressed. And these are the research areas that are openly available for our VANET and IoT systems. And these are the finally coming on to the conclusion. These are the IoT, VANET projects that are supported in the various countries like German, Japan, Netherlands, France, Italy, and some Sweden. These are the projects, VANET projects supported for getting over all these objectives. And you can have as many as devices supported here. And for example, you have this Toyota friend in Japan for getting over Twitter informations in the car when you're on the move. So this is just an infotainment related information. And coming on to another infotainment related information, you can get over the radio access in our network. For example, in the Sweden, that is again an infotainment related information. And in this METIS, which is implemented in Europe, you can get over again infotainment related information. And the safe spot in implemented in Italy. So this is related to the road safety information, traffic management information. Like that, how the projects are there, various projects are there implemented in the various countries related to the various applications of VANET are presented over here. So this is a small insight about the various applications of real-time applications that are present in our VANET. So like this, coming to the conclusion, we have various challenges are also in the VANET related to the IoT integration. Without the sensors, the VANET cannot survive, and there are lot of applications related to the road safety, related to the traffic management, related to the infotainment, related to the weather management. All those things we have various applications also prevailing. Even though they are developing phase, we have lot of researches going on in this area. So finally, I want to conclude that this is a great area of research that can be supported with a lot of research works under security, energy conservation, and also routing. So With this, I wind up the session. So hope it is some insight to you all got about the VANET and what are the applications, what are the challenges that are faced, and what are the integrations that are going on with the IoT. All those things I have given an insight. Thank you all, and you can give over any queries can be addressed.
Thank you, ma'am. That was a very informative session. We got a lot of information about the security challenge in VANET and the various protocols. We have a question into the chat from Dr. Ahmed.
Yes.
He is asking how did you determine the impact of the attack, whether it is high, medium, or low?
Yes, related to the security attacks. Yes,
Right.
Right, ma'am.
yes. It has been presented over here. How whether it is supported by the impact. It is related to the impact of the attacks. So that is whether it is tolerable or whether it is have to be addressed immediately. For example, it is vehicle to vehicle. In this case of denial of service, it can be considered as a medium one. For example, I'm not getting over a service about the entertainment that is happening over in my area that is being attacked means that can be tolerated. That can be tolerated to a medium extent. Okay. And suppose if I am getting over jamming service, that is jamming attack, that is I am not being provided about the immediate traffic information from the vehicle or the vehicle to infrastructure. I am not getting the traffic information. Okay. So that is a highly impactful attack. I cannot tolerate that one. Okay,
All right.
because I need the service immediately about the traffic, but this one is tolerable. Spamming attack, the advertisements that are coming over, that can be tolerable. Okay, so that and all minor one, they don't have any risk and they are low attacks, that they are tolerable. Even eavesdropping, that will definitely happen in an VANET network because the informations are being broadcasted and someone will be tampering into the network and they will be trying to hear our information. So that and all low attacks and that and all tolerable. So this is how we classify the attacks. But this GPS spoofing, this and all critical attacks which we have to be addressed immediately.
Great. Or we can say that these kind of attacks impact and severity also depends upon situation to situation and location to location.
Yes, definitely, definitely.
All right.
Depending upon the application that we are trying to access. Whether it is infotainment, we can compromise. But whether it is traffic related or road safety related, we should not compromise.
Great.
Right.
So I would request our all other participants to please discuss any technical query related to this topic.
Also, ma'am, we have one more question from the chat. Does VANET have relation with the 6G networks?
Yes, whether it has relation with
6G networks.
Zigbee.
6G, 6G.
Sixth generation network.
6G. Yes, 5G is deployed over here. But when we go for 6G, definitely the energy consumption will be more. And till now, it is prevailing in the European countries only. So it is well enough with the 5G itself.
All right, ma'am.
All right. Apart from this, I have a very usually when I read the research papers, I feel there is very thin boundary between the VANET and IOV. So the distinction between the IOV and VANET and the protocols or the security challenge are little different, but several research papers have merged them into single topic. So is that feasible to merge them into single, or they're really different?
No, sir, definitely you are correct. There is definitely a thin line between the VANET and IoT because it is also using the 5G network and the same standard technologies that the VANET is using, the LTE. Only thing when we go for the wave or the dedicated radio network that is used in the VANET. During that time only the protocols may vary, little bit vary. That too in the physical layer and the medium access only you have the difference. Other than that, the protocols can be interchanged and used in both the things.
Okay. So because with the application of UAVs, unmanned aerial vehicles like drones, the connectivity enhancement into VANET is also increasing with the help of drones to uh, provide the connectivity in those areas where like RSUs are very difficult to deploy. So
Yes.
UAVs are being used, and the communication between the vehicle, UAV to the server, it is creating the 6G network with the ubiquitous connectivity and continuous connectivity.
Yes, sir. UAVs can be used over when the RSUs are not deployed during that time. Yes, definitely we can go for the advanced networking technologies and get over the VANET in a good communication area also, with a great communication also. Yes, it's highly possible.
Great. Thank you, ma'am. And there have been a demand for your this PPT from our participants. Like it is very informative and very concise information is being provided into this presentation.
Okay,
So
sir. I
probably
will
there were.
happily share it, the thing. I will happily share it to your team and you can share it to the user.
Great. Thank you. Thanks for this webinar, ma'am. So I would also again request to our other participants, if they have any other query, please discuss. We are also having. Okay, if someone want to connect with the professor, they can connect to our platform. The profile of professor is available on the platform and is being provided over into the chat again. I would request Lakshay to
Yes,
share the profile link into the Google Meet chat also.
sure, sir. I'm just sharing.
And Dr. Ganesh is having a question. He's asking, how about suggestions on tools apart from NS2, 3 with Sumo and MATLAB? Any open source tool?
Yes, sir. We have the Sumo as a great simulation tool for supporting the VANET. And apart from that, you can have go for the Qualcomm or Qualnet also, which is also a great environment, but it is proprietary based. Okay, so we can't use that one. But lot of protocols in the Qualnet are very much supporting the VANET environment. So I have used the Walnut here, integrating the security part, and so it is a great one. And with the Sumo, you can get over the just visualization about the thing. With the MATLAB and other thing, you can go for little bit analysis. But Qualnet is supporting the protocols and the simulation together for the VANET. So it's a great platform to work on.
All right. He's saying thank you for your answer, ma'am. Another participant, Dr. Agustina Anura, is asking which part of the VANET can one integrate with the blockchain?
So integration of blockchain is mainly done over for supporting over the security purpose, and you can go for the OBUs, and you can also go for the application units integrated with the blockchain.
Right. So basically, it is that part where vehicle is sending data to the RSUs or to the server. That part can be
Yes.
more secured with the help of blockchain.
Yes, there you have to have the blockchains implemented.
Okay. Thank you, ma'am.
Hmm.
So, any other question from our participants, from dignitaries?
Okay, ma'am. So I think there are no more questions as of now.
Okay, sir.
Yes. So we would like to, thank you all the participants and you for such a insightful session that you have conducted.
Thank you, sir. Thank you.
And also, we wanted you to share the presentation as it is.
Definitely, definitely.
Yes, ma'am. So thank you to all the participants and to the ma'am, and happy New Year to all of you once again.
Thank you, sir. Thank you very much. Thank you, all of you, for the kind, patient listening and also for the queries that you have raised. Thank you all. And I will share the PPT with the team and you can get it over. Thank
All
you,
right.
ma'am.
All right.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Thank you.